So welcome back to this lesson. So in this lesson, we want to look at lesson 5 of our domain 1 of agentic AI business solution architects, AB-100, plan AI power business solution, architect agentic first business outcome with Microsoft AI apps, service foundry tools, Copilot Studio, Dynamic 365 Power Platform, governed enterprise data, okay, which carries 25 to 30% of the entire domain of the entire agentic AI business solution architect, AB-100. Okay, so let's look at what we have next here. Please, if you are just joining us, please like and subscribe. So let's look at a platform decision. So the next in our previous discussion, we look at planning, or implementation, full implementation workflow, implementation architecture, which is strategy to planning, to readiness, to governance, to governing and operating. So strategy, plan, ready, govern, operate, which is cloud adoption plus AI agent lifecycle management. That's what we look at. So platform decision, how do you choose platform? We've looked at how you can choose data platform and the available data platform that is available on Azure for RAG implementation and warehouse and lakehouse implementation. Now, how do you choose your SaaS platform? Where should you deploy? If you build in Office 365, where should you, if you build in Copilot, where should you deploy? If you build in Foundry, where should you deploy? If you build simple agent, even in Foundry, where should you deploy? If you build multi-agent and complex system on Foundry, how should you deploy and where should you deploy? So that's what we are looking at in platform decision, SaaS first agent strategy, software as a service or solution. So platform part and best fit. So look at what we have here. The first one we have is Microsoft 365 Copilot. So Microsoft 365 is also a platform where you can deploy your agent, particularly if it is built in a Copilot Studio. Okay, yeah. So we have Office 365 Copilot. So productivity work in Office 365, drafting, summarize, knowledge and meetings. So you can deploy your Copilot. You can integrate you can deploy in Office or a Microsoft 365 Copilot, for instance. That's if you want to integrate with Microsoft 365. If you want to integrate with Outlook, with OneDrive, with all those things, you want to integrate with Teams. Yeah, you can integrate your agent with Teams, drafting, summaries, knowledge and meetings. So you can use a Microsoft 365 Copilot. You can deploy a Microsoft 365 Copilot. Then Copilot Studio. So this is low-code workflow agent, retrieval, action, business process, and automation. So what we are saying here is if you are using paid Copilot, you can see an option for creating agent. Even me myself, I've created agent there. So you can create simple agents like summarize, data analytic agent, drafting agent, summarizing agent, knowledge agent, meeting agent, simply in Copilot, in Microsoft 365 Copilot. So that's very useful. Then you can use Copilot Studio. So Copilot Studio can help you build more complex agents that Microsoft 365 Copilot cannot host. So this is low-code workflow agent, retrieval action, business process automation. And when you build in Copilot Studio, you can still integrate with Microsoft 365 Copilot. You can integrate with Teams. You can integrate with Dynamic 365 and other Microsoft 365 tools. The Microsoft Foundry is another platform where you can build your agent. So this is enterprise agent system, reasoning, tool-rich automation and evaluation. So if you want to build custom agent or multi-agent system and workflow, you can use Microsoft Foundry. Okay, so which is used for building custom use case and multi-agent system. Then GPUs and containers. You can deploy agent that you build in Microsoft Foundry using GPUs and containers like Azure Kubernetes Service or Azure Container Apps or Container Instance. So this give you full control, specialized compliance, custom infrastructure, and high autonomy. So you have high autonomy here and the implementation for custom and multi-agent system. Decision principle: evaluate SaaS agent first, then extend the building only when justified. So evaluate what you want to build. Okay, know the complexity. If it is simple, build for simplicity. If it is complex, build for the complexity. So if it is simply drafting, summarization, knowledge, meeting notes that you need, you can simply use Copilot, Microsoft 365 Copilot to build that. Then if you want a little bit complex workflow, combining complex workflow together, for automation, then take it to Microsoft Copilot Studio to build. And then if you want entirely custom agent, complex enterprise implementation, full autonomy, tool rich, and custom building evaluation with Python, C Sharp, and the rest, then you use Microsoft Foundry, and then you'll be thinking of choosing the platform to deploy using container apps or Azure Kubernetes service, AKS. And so choose platform based on the complexity of the agent. Slide, we have single agent versus multi-agent decision. So how do you know where to choose single agent, and how do you know when you should use multi-agent architecture as an architect, as an agentic AI business solution architect? So here we have the list of the use cases, single agent to multi-agent to the type of agent, and when the solution has, when you have to use these use cases. Okay, so when it is needed in a solution, as a solution to a pain point. Okay, so for single agent, we have one business domain, lower complexity, quick deployment, clear task boundary. So like we said for example, I will always use procurement for example, because it is a distributed business domain. There's many activities combined together. You can have 10 activities: contract administration or supplier administration. You have contract awarding, analytics, finance, and everything. They are just interconnected together. So I'll always use that as an example because it is a distributed use case. So for example, if you want to build an agent for a contract admin, that would be a single agent because that is just a single task. Okay. So single agent is used for single use case in a business domain, just like you have a business department, and in the department you have several units. So if you are building to solve the problem of a unit that is handling a task, one task, then you need single agent for that particular situation. So if the task require a lower complexity, the task is simple, quick to deploy, and easy, just a simple task, go for single agent. Multi-agent, used for multiple domains, security boundaries, specialist rules, complex workflows. So if you want to build for an entire domain, entire business department, like the entire procurement department, where you have all the activities combined together, entire supply chain department, entire finance department, entire HR department, entire IT department, you want to use an agent to solve the problem of an entire department where you will have multiple tasks combined together, or multiple actions combined together to form several units of tasks, either to be done parallel in a parallel way, on a sequential way, or in any way they want to do it, in as much as you have combination of tasks, in as much as you have distributed task that is not just one. It can be simple, but as long as it is more than one, then you have to use multi-agent. So multi-agent is needed in multiple domains, multiple units, and for multiple tasks. Planner. So just like as we have seen, a planner agent is the one responsible for receiving action and then turning the action into a plan. So a planner receives an information from maybe the user or from the front end of the application, from the ERP system, or from Tuga, or from email, or from wherever the action is coming from. It receives the information and then plans it. So the planning break the information into an action, and then from action into a unit of task. So it can break the action into like several tasks, okay, and then distribute that task into specialist agents that will undo the task. That is the work of a planner. So its break goes into step and coordinates execution. So if you need a task that must be done in a sequential way, like a procurement process or supply chain process, or any other process that just follow a sequential way or parallel way, anything that needs to be broken into, actions or tasks that will follow each other or that will be done at the same time, as long as you have combination of many tasks together, the planner agent is useful. Researcher. Researcher receives and synthesizes knowledge from trusted sources. So if you want to build a knowledge repository, if you want to build a summarization agent, for example, if you want to an agent that will go into the database, look up information, summarize, and give you, summarize information in form of a PDF or PowerPoint or Word document, then you need a researcher agent. So you connect your knowledge repository, maybe SharePoint, OneDrive, database warehouse, Fabric OneLake, Azure Data Lake Storage, Azure Cosmos DB, MongoDB, or external sources, wherever you have the resources coming from, either even in your data first or in your Power App application backend and everything. Just connect the knowledge source and then connect it to the researcher agent to go there, receive the information, summarize the information, and turn the information into a document that you can use. Then we have reviewer agent. So this is used for validating output, policy fit, completeness, risk, and quality. So if you are building a platform that we use, that if you need an agent to validate outputs, okay, maybe after you've used planner agent, researcher agent, you need a validation agent that will review what the researcher agent has done, that will review what the planner agent has planned, then you need a reviewer. So the work of a reviewer agent is to validate outputs coming from any sources, whether it is text, whether it is summarization, whether it is meeting notes, or whether it is visuals or analytic notes or any information as well, whether numerical or whether numerical or textual. Then as long as you need the information to be validated, you need a reviewer agent. It is also fit for policy. Its reviewer agent acts as a guardrail, okay? So it's not human in the loop anyway. This is not human in the loop. It's an agent as well. It acts as a guardrail. It passes any information coming from other agents through the policy to filter out information that are not policy fits, okay? And then it redacts any information that is against compliance, against policy, and then pass on information that complies with the policy. Then it's needed for completeness, to check the completeness of the output of every other agent, to check risk, whether whether those information are secure and are not risky for company consumption, and it also checks for quality of the output of the other agents. So reviewer agents are just like guardrail that filter information for responsible use of AI. Then we have actuator. So an actuator agent executes action through tools, connectors, API, and workflows. So the work of an actuator is to execute action using tools. So this is just like agent that call tools, okay? It look at what is coming. Okay, this is task 104, or let me call agent 23. Agent 23 can handle this task. Then it's called agent 23. That's agent to agent communication. So it look at, okay, task 104, okay, tool 7 can undo this work. So it pass the task to tool 7 or calls tool 7 to execute the task. Then if it needs or if it is start that need a connector anywhere, it calls the connector. If you need, maybe you want to use data from any other source, maybe API or any endpoint, it calls the API. And then if you need to connect to other agents in the workflow, then it calls the workflow or connect the agents to another agent. So that is the work of an actuator. So these are different use cases: single agent, multi-agent planner, or researcher, reviewer, actuator, and these are the function, the use case, and when you need to choose them. So know when to use specific agent. Do not use multi-agent where single agent is enough. And for multi-agent in particular, planner agent is always needed. Any task that involves summarization, research agent is needed, and almost all the agent need reviewer and actuator, because every information that is being generated, whether from single or multi-agent, needs to be passed through guardrail for policy compliance. All right, on slide 24, we have multi-agent orchestration pattern. Okay, so I wrote a book on multi-agent orchestration pattern for enterprise scale system. So if you have not read about it, please kindly go to Amazon. I will drop the link below on as part of the description of this note. Please check on Amazon and get that book by Funke R. Yusuf. I'm the author. You can also get it on my website. Okay, so it's very, very important that you know multi-agent orchestration. We have different orchestration patterns. We have about 10 or 12 of them. In fact, they are increasing daily. Okay, we have sequential orchestrator, we have parallel orchestrator, we have hierarchical orchestrator, we have manager worker orchestrator, we have centralized orchestrator. We have many of them. There are many of them that we have. So for the sequential, so an orchestrator, just like you have in music, an orchestra coordinates musician. It coordinates the flow of a music. So also that is also the work of an orchestrator in multi-agent system. Orchestrator coordinates every other agent to act accordingly, to execute the right task, to communicate the right way, and to, it's just that is just coordinates them around, assign tasks to them, and see to it that they complete the task and monitors them. So orchestrator is just like the overseer of every other agent in the system. It is very, very useful for building multi-agent enterprise system. So the first type of orchestrator we have here is sequential. So sequential, as the name implies, step by step, from one step to the other, and the steps are interconnected linearly. So that's sequential. So in sequential, we have the planner, we have the analyzer, we have the validator, we have the executor. So sequential orchestrator coordinate agents sequentially. So all these plan, analyze, validate, execute, they are agents. Okay, so this is planner agent, analyzer agent, validator agent, executor agent. Then it passes the action from planner agent to analyzer agent. Analyzer analyze and passes to validator agent. Validator validates by using company policies and pass on to the executor. Then the executor executes the action and the loop ended. So that is sequential orchestration. It coordinates agents sequentially. Then we have concurrent orchestrator. So here you have specialist agent work at the same time for speed. So all specialist agent work at the same time, concurrent, that everything happens together. Everything happens at the same time. So when you are using concurrent orchestrator, it coordinates all the agents together. So that means when a planner agent is working, analyzer agent is working. When agent A is working, agent B is also working, agent C is working. So it just receive a task and plan the task and break it down, and then just spread it out to every other agent to take it on and start working. So one agent is not waiting for another agent. Okay. So this is very good for companies that build swarm of agents, that build many agents, maybe 50 agents, just swarms together. I've not built any swarm agent. I'm going to try to build one swarm agent, and you are going to see it on my YouTube video. Then we have a group chat orchestrator. So here you have moderator, coordinate, specialist, agent, and resolve consensus. So in a group chat, just like you have a normal human group chat, you will have a leader, you will have a moderator that is moderating the chat. So every other person is permitted to talk. Okay, everybody will say their mind, what they feel, and their thoughts. Everybody will drop their thoughts. Then the moderator will moderate everybody's inputs, and then come out with the best, and then give the conclusion. So that's this, like human group chat. So moderator, coordinate, specialist, agent, and resolve consensus. So the work of a moderator agent here is to check what every other specialist agent has done and then resolve consensus. So here, just like human being, agent can disagree. Okay, agent can disagree on task. Agent A can subscribe to a task, agent B too can subscribe to the task. Then both of them will now be deliberating who should take this task, who should take this task. So in that kind of case, you need a moderator or agent that will coordinate and resolve this issue among agents. So when you have a moderator agent will determine a task that is, relevant to an agent. It will determine a task that an agent can handle. So instead of agent queuing and, fighting for task, moderator agent look at the task and look at the right agent, specialist agent to give it to, and then passes the task to the specialist agent so that there will not be confusion of who should do this task and or confusion in the system. So a group chat allow moderator to resolve issue between agents, to distribute tasks to agents, so you will not have chaos in the system. Then we have handoff on orchestrator. So handoff escalate work to another agent or human owner. So handoff orchestrator look at a task. It's then just like you have in group chat where you have moderator that coordinates specialist agent and resolve consensus. In handoff agent, so handoff doesn't perform the task. We doesn't do anything. It only look at the task, okay, and assign it to an agent or assign it to human, and then it's hand off. Nothing, no feed. It doesn't receive any feedback, okay, from any agent. So it's escalate work to another agent or to human for approval to take over. Then we have magnetic orchestrator. So here you have dynamic agent selection at runtime based on context. So magnetic, just like you have a magnet that attract ions, it doesn't attract any tools that is not ionic. So magnetic agent also select agent at runtime based on context. It selects agents that is most suitable for the particular task. That is, whenever there is a task, you check the context in the task and just immediately pass the context to the agent that owns the task. That's the work of magnetic agent. And then we have human review. So this is required for critical decisions to controlled by accountable people. So you have human coordinator or human in the loop. So any task that is sensitive, that is, involve a high financial, output or input, or any task that is risky, that you cannot allow agents to handle in the company, sensitive task, then you need human in the loop orchestrator. So it's not that the human is orchestrating other agents and making activities slow. No, the task must have passed through agents. Then validator agent will have determined that, okay, no agent should, according to policy, no agent should handle this. This task will be passed to human, and then it is passed on to human for approval, and the task will not continue until human approves it. So this is multi-agent orchestration. If you want to learn more about this, please, I have a series of 10 videos taught from the content of my book, Multi-Agent Orchestration Pattern for Enterprise Scale System. So you can watch the video and also get the book on Amazon. Okay, so we have Copilot Studio and Foundry design rules. So solution constraint. We are moving gradually to core content of the solution architect. Remember, we are still in domain 1, and very soon we'll be rounding up with it. So we have a Copilot Studio and Foundry design rules. How do you design in Copilot Studio? Copilot Studio is used for designing agents that you want to integrate with Dynamics 365 or Office 365. And it basically uses agent flow. You have tools, you have computer use, you have where you can put your prompt, and you can connect to several base model like Copilot itself, Copilot model itself, which is for Microsoft. You can use Claude as your base model. You can use a GPT. You can select any model, whether small, medium, or large, based on the complexity of the task. Copilot Studio can also be used for multi-agent. Okay, so as long as you are not building custom agent, but as if you want to build custom agent, you have to use Foundry. Okay, so Copilot Studio, rule and constraint. Copilot Studio is best for retrieval agent, workflow automation, low-code solution, topics, knowledge, actions. So Copilot is used for building simple workflow, whether a task that involves single agent or multi-agent, as long as it is workflow, it is just like workflow, like that you can simply connect agents together like you have in N8N or other tools. So use Copilot Studio. Copilot Studio controls. In the controls, we have connectors that can allow you to connect to tools and other tasks. You have the define task boundary, where you can define the task boundary. You can give system prompt and user prompt. You can apply DLP for data protection, anonymization and minimization. And then you can also connect with organization policy documents through SharePoint connector or OneDrive connector, OneLake, or wherever the organization document is. So you can connect to it. Then we have Microsoft Foundry. Microsoft Foundry is best for complex reasoning, best for building custom or multi-agent system. Okay, so when you want to build, when you need multi-agent system, tool rich or automation or RAG, automation that involves RAG or vector database, anything that involves complex or custom agent, then make sure you use Microsoft Foundry. The best for complex reasoning, multi-agent system, tool-rich automation, and evaluation, and fine-tuning as well. It's RAG, Microsoft Foundry is good for that. Foundry controls. So the kind of controls that you have in Foundry are use scope permission, evaluation pipelines. You have monitoring, you have governance, you have model security. So in governance, you have role-based access control, attribute-based access control. You have governance, you have purview there, you have security, and you have you have many models. Okay, there you have GPT, all the GPT series, you have all the Claude series, you have other model like Grok, like Kimi, K3, and Quem, and all, even Copilot itself. So you have many base model that you can use, and then you can also define your system prompt and user prompt. You can define your you can connect to RAG database, connect to other data sources as well. Then you can use completeness if you are building a chatbot, or you also have a playground where you can test your agent before you deploy into production. And then you have shared constraint. So never give agent unlimited scope or unmanaged enterprise access. Remember, even though you have access to connect the agents to databases and everything, always make sure you use adapt. We've discussed adapter like MCP server, okay, as a bridge between enterprise data and agent, okay. They never expose the whole organization data to the agent. Always use the principle of minimization and anonymization. That's least privilege and role-based access control. All right, let's look at the next thing we have here, which is knowledge design. Okay, so in knowledge design, we have knowledge sources for Copilot Studio. So knowledge design is, giving the agent grounded knowledge, giving the agent more information about the organization to prevent wrong information, to improve quality of the agent output, and to prevent against hallucination. Okay, so because base model are trained with large corpus of data that are not the company data, so it can be using all this information to answer you instead of company information. But when you connect company knowledge to the agent will use the company, it will use the base model just as a brain, and then use the company knowledge to process information, thereby improving the quality of the output and the answer it is giving you. So-called knowledge source for Copilot Studio Agent. We have data type, recommended knowledge sources. So for structured business data, so recommended knowledge sources are Dataverse, Govern, Dynamic 365 data. So if you need structured data from enterprise business applications, so connect to Dataverse and Dynamic 365 data. If you need semi-structured content, connect to Azure AI Search for semantic database and vector retriever. Okay, so you can use Azure AI Search for this. You can use PG Vector. You can use Azure DynamoDB search index. Azure SQL database also now supports vector database. So any of this can be used. Unstructured content. For any unstructured content like files, like any unstructured data, whether in file, in PDF, in document format, or in JSON format. So you can connect to SharePoint or OneLake, Azure Data Lake Storage Gen 2, Blob Storage. You can also connect to OneDrive, and connect to Cosmos DB, for instance, for unstructured information. So for files, document and PDF, SharePoint, and OneDrive. Okay, so external knowledge. So if you want to connect to external knowledge, use enterprise connectors. Okay, you will have built maybe MCP2. You will have MCP2 that you can use to connect to company database like SQL Server on-prem or wherever, or SQL database or warehouses, anywhere you have information, even MongoDB. So use enterprise connectors. An example is custom MCP server or govern APIs and endpoints. Then generative grounding. So for generative grounding, to retrieve generative grounding from RAG databases, use Azure OpenAI on your data and retrieval pipeline. So you need Azure OpenAI to retrieve your data. You can use any of the models available in the Azure OpenAI like GPT, like GPT-4 or GPT-5, like Claude, any of the Claude models, Sonnet, and thereabouts. So you can use them as generative grounding for retrieval. Okay. So then scale notes. Knowledge design must consider source limits, permission, and freshness. Make sure that you do not use old knowledge to supplement your agent operation. Okay. Old knowledge will still allow the agents, even if the old knowledge is complex information, as long as it is out of date, as long as it is not the knowledge that the company is currently operating on, it is still an old knowledge and it is not relevant for building the agent. So use current up-to-date knowledge to supplement the agent information. So knowledge design must consider source limits, permission, and freshness. Permission is also very, very important. Do not give access to the whole knowledge. Give access to only the knowledge that is needed for the task. Okay, limit access to what is needed, and then make sure every PII information are always redacted, and what needs to be encrypted are encrypted. All right, so this is the end of this section. When we come back, we'll continue to the next section.